Hello, folks. Thank you so much for joining today. And I'll kind of get started in like 1 to 2 minutes. There are roughly around 570 people in this meeting. Just want to get some feedback. How many of you attended yesterday's webinar? Yesterday was a mechanical engineering webinar. I don't know if you attended that or not. So can you just let me know if you have attended yesterday's webinar so that I can get an idea? Viraj, yeah, thanks, Viraj. Okay, Mohammed Reyes, no. Folks who have joined, can you just let me know your domain of graduation, which domain you are studying, electrical, electronics, ICE, and which year you have graduated, right? Your domain and graduation year. So, Amish, 2013, MCA, 2019, 2017, 2010, 2024. Great, sounds good, super. So we have a mixed lot of people. I think a lot of 2022, 2023 folks, and then also a lot of folks from previous with experiences. How many of you have industry experience, electrical engineering industry experience over the last more than 4-5 years of electrical engineering industry experience? How many of you are working in the EV industry or as an embedded systems? If you can just post your comments out here, that will be also helpful. Okay, Afrin, Amaraja, Bajaj, Amaraja batteries. Oh, okay. Super. Thank you so much, folks. I'll start sharing my screen and I'll kind of get going. Let me know if you guys can see my screen. Can you guys see my screen?
Yeah, we can see it.
Thank you. Super. I'll kind of get started. In this, I'm going to split this into 3 parts, right? The first part is very, very introductory. In the introductory part, we will be looking into what are the macros that are happening in the world that is affecting not only mechanical, but also electrical and civil engineering domains, right? So what are the macros that's happening? And the second part is where we look into electric vehicles and what are the opportunities in electric vehicles. And the third part is embedded systems and what are the opportunities in embedded systems, right? So this is how we will kind of look today, right? I'll kind of let's make this interactive. So anyone, if you have questions, post in the box, right? I have my chat as well, so you can ask questions while going on. If I'm essentially in a particular topic, I'll kind of come back to your question a while later. So just wanted to say that, right? So who are we? So for folks who do not know about Skill-Lync, how many of you have enrolled in a course in Skill-Lync? Are there any students who are currently a Skill-Lync student attending the webinar right now? Shubham, Rajni, great. Arun, super, great, sounds good. So there are a few folks who have already enrolled. Hanuman, Trithik, great guys, sounds good. So so for people who do not know about Skill-Lync, Skill-Lync is an online engineering education platform. So we provide courses in specifically electrical, electronics, civil, and mechanical engineering domains, where we feel that there's a gap in the industry and we feel we have the ability to bridge that gap, right? So that's what we do, and that's what we have been doing for the last 5-6 years. We have helped almost 30,000 plus students over the last 5-6 years. Almost 350 companies hire from us, hire our students, 250 plus courses available on our platform. And we've been lucky to have roughly 2,000 employees working across 4 cities, right? So yeah, so just I'll kind of quickly go to the next slide. I wanted to speak about the macros, right? That's, as I said, that's segment 1, right? What are the macros? So there are 5 significant events that is essentially moving India as the next manufacturing or the engineering research and development country, right? So I'll kind of start with one question. This question is a repetitive question. I asked it in yesterday's webinar or in the webinar that I took on Saturday, but I'm going to ask it, right? Where did COVID originate from? Which country did COVID originate from? Abhinav, right? China, right? So China was where essentially Wuhan, China was when COVID originated. And when COVID hit China, one of the things that they did was go into something called a zero COVID policy, right? I'll repeat it again. It's called a zero COVID policy. So I'll also ask you to note down something that you can go and research in your free time on Google. So zero COVID policy is one thing that you should note it on. So what happened was, what was zero COVID policy? China simply said, until there is nobody affected with COVID, there is going to be a strict lockdown. And when they put a lockdown, what it meant was they essentially made China isolated. So nobody can fly in, nobody can fly out. What did it do is, when nobody can fly out, the parts that they manufactured was not able to go fly out as well. So essentially the manufacturing was stopped and supply chain was broken. Who do you think is one of the major contributors of manufacturing? Which is the country that manufactures a lot of products? Which country manufactures a lot of products? Saurabh is saying China, Shubham, China. Yes, right? A lot of products, almost I think world's 25% of products or manufactured goods comes from China, right? I might be wrong in the data as well, but that should be in the ballpark, right? I think a significant part of components that are manufactured come from China. And when China went into a zero COVID policy, the supply chain broke down. What do you mean by a supply chain? Supply chain is essentially nothing but supply. Give me 1 minute. Supply chain is nothing but essentially, if you manufacture something, you need to you manufacture it in China and you assemble it in Europe. You need to ship the component from China to Europe and assemble it, and then sell the assembled component, assembled full product. Now, when the supply chain got broken, all the big companies across the world came up with something called as a China plus one strategy. Again, this is something that you should Google, which is called China plus one. What it meant was, when all the top companies in the countries started realizing that you need an alternate supplier or 2 to 3 suppliers, not one particular supplier, and having high concentration of manufacturing. And some of the countries that came up are Vietnam, Indonesia, Brazil, Mexico, and so on, right? And one of the primary countries that came up was also India, right? India became one of the primary countries because of 2 reasons. One is, we have the highest number of engineers graduating every year, right? Highest number of engineers graduating every year. India is the highest. India is the country which graduates the highest number of engineers. Almost 25 to 23% of engineers in the world graduate out of India. The second thing is, India has a lot of English speaking engineers, right? Very simple. These are the 2 things why India essentially became one of the prime reasons to become an alternate to China. Now, was this the 2 reasons alone? Not primarily, right? So these were one of the reasons, one of the biggest reasons. If you essentially put down the top 3 reasons, this should be in the top 3 reasons. The amount of people, engineers, and the English speaking engineers, right? This will be in the top 3 reasons. Then the other thing is production linked incentives. What India is doing is, I'll kind of also speak about something that I have not put here, which is called as Gati Shakti, right? Gati Shakti, GATISHAKTA, Gati Shakti program. You should Google this also, Gati Shakti, right? What does Gati Shakti program mean, right? In India, there is a lot of infrastructure. If you are in a tier 2, tier 3, tier 1 city, irrespective of the city that you are in, there should be road expansion, there should be subways being built, there should be metros being built. Are you seeing that? Are you seeing a lot of infrastructure development happening in your cities? Right? So Shubham is saying yes, right? So what is happening here, right? So see, to manufacture, if you're buying a product, what are the two primary cost of the product? The first cost of the product is raw material and manufacturing. The second important cost is the logistics, is the transportation of the product from the raw material to the manufacturing facility, to the manufacturing facility, to the assembly unit, to the assembly unit, to the end customer, right? This whole transportation is where the second largest cost of a component becomes, right? This is where India essentially said, if we need to become a manufacturing hub, if there needs to be a lot of product companies that are setting up spaces in India, we need to build our infrastructure. Our ports need to be, there needs to be a lot more ports. Our port size should be increased. The connectivity between states should be faster, and that's why the road expansion is happening, and that's all happening under the Gati Shakti plan, right? And the third thing is essentially, the first thing that kickstarted is essentially China plus one. But even before that, the government essentially started thinking about, okay, if manufacturing needs to happen in India, you need to have a good infrastructure to transport these components at a faster pace, and therefore infrastructure projects are happening. And the third thing is production linked incentive, right? In 2013, right, we had 10x, 10 years back, we had 10x lesser number of mobile smartphones, right? 10x number of mobile smartphones, but 97% of those smartphones were manufactured outside India, right? 97% of the smartphones that were used in 2013 were manufactured outside India. Right now, we have 10x more smartphones. 92 to 95% of smartphones are manufactured in India, right? So this is a huge jump, right? Why has this jump happened, right? The primary reason is that over a period of the last 4-5 years or 6 also years, what the government did was production linked incentive in electronic components, which meant essentially if you manufacture the component in India, you will get subsidized electricity for manufacturing, you will get land for setting up your unit, you will get tax exemption for a period of time, and many more incentives to make sure the companies come and build and manufacture in India. And similar to that, right now, there are three major PLIs going on. One is in the semiconductor industry, right? Almost 20,000, 17,600 crores, I think, in the semiconductor industry, where people are saying, where the government is saying, we want to become one of the main semiconductor manufacturing areas, right? And Intel, companies like Intel, who are the leaders, right, are trying to essentially see if they can set up plants in India. So Google this semiconductor PLI. The second is electric vehicle, right, or automotive PLI. So government is saying, set up your manufacturing hub and build vehicles here. We will essentially give more discounts, right? The third is essentially what you call as a defense PLI. So India was a significant percentage of the equipments that we used in defense, probably a few years back, I think a decade back, would be large. So 50-60% would be exported. I think right now 50-60% would be imported, right? We would essentially, for our defense requirements, we would import. And right now we export to almost 75 countries. Now, India sees that as an opportunity to set up a lot of build defense components in India and essentially export, right? All these three essentially mean a lot more jobs that are coming up in India, right? So the reason I'm saying this is to make sure a lot of us, right, as I'm a mechanical engineer, right? But I know you are electrical engineers, mechanical, electrical, electronics, civil, irrespective of your core branch. One of the most common assumptions and the phrases that we would have heard in our undergrad was core engineering jobs does not pay well. Well-paying core engineering jobs we will not be eligible for that. Have you guys heard this? And all of us need to essentially take IT jobs. So have you guys heard this phrase, right? These are the three phases, right? IT, irrespective of a electrical, electronic, civil engineer, you should get an IT job. Or if you're a core engineer looking for a core engineering job, you will only get a low paying job, right? So you would have heard about these things, right? So, but I want to kind of say these are very, very, this might be true. I don't know if it is true also, right? This might be true while back, but the amount of job opportunities in India for core engineers is booming, right? The amount of job opportunities is booming, and that's one of the things I wanted to speak today in this webinar, right? Because I wanted to kind of make sure a lot of us, right? When I graduated from a tier 2 college in 2011, right? I got into CTS at a 30,000 rupees job, right? And I realized that as a mechanical engineer, I did not want to pursue software engineering or being a software analyst or a quality analyst, right? I wanted to pursue mechanical engineering. That's what I was. So I had to go pursue my master's, work in the US, and then essentially realize that, okay, what we miss in India is not the theory, it's the practical application of theory, right? So that's the reason why we build Skill-Lync. But what we miss in India is not the talent. All of you are talented. The thing that we miss is the skill, right? What we miss is the skilled talent, right? And so that's one of the main things, right? I'll skip the EV revolution, industry 4.0 and sustainability. You all know that. So I'll kind of go next. So today, right, I'm going to look at India's electric vehicle and embedded system, right? The number of job opportunities in embedded systems and in electric vehicles, right, especially in model-based development, is very, very, very high, right? We see almost job requirements for, so we place almost 200 students every month, but we see almost openings for the companies that we help hire itself have 1,500 openings every month that we are not able to fill, right? Because of the lesser amount of flow, right? So Teja Siva Shai, right, in the comments said the amount of job opportunities are good in India, but most of them are going to IT companies for better package. Core hardware companies give less package first, and later it has good growth. Could you please share your growth? It makes inspiring, guys. What Teja Siva Shai says is extremely valid, right? The other thing that I want to say is even the IT sector right now pays low only. Say in my when I graduated 12 years back, they were paying 30,000, 3,60,000 package. Wipro, Infosys, TCS after 12 years also pays 3,60,000. A good embedded engineer or a good model-based development as a fresher gets 4.5 lakh rupees in Cyient, Quest Global, Mahindra and Mahindra, Tata Technologies. In every company, right? In every company, a good fresher with 60% and above GPA in 10th, 12th, and undergrad, and also if they have a little bit of understanding on embedded systems, right, and have done 10 plus projects in the embedded systems or in model-based development, right, your ability to crack a job is extremely, extremely easy, right? That is your first, even say, for example, even, so there are people who will get 3.5. So, but I have not seen people in electrical electronics engineering getting below 4 lakh, right? It might be 3.6, but below 4 lakh, I have not seen. I'm saying for freshers, experienced people get more also, right? Now, if you go into a particular domain and work for 2-3 years, you are seeing, what we are seeing is, especially in the core engineering sector, the amount of opportunities and the growth is actually faster, right? So yes, in IT sector, Google, Facebook, everyone pays higher, but it's only for a small section of people, right? And all those people are getting fired right now, right? So all those people essentially are getting fired because and if you think about this, all these high pay was only in the last 5-6 years, right? Not before that. And what's happening is there's a market correction that's happening in the IT sector, right? There will still be people paying higher, but it will only be a smaller portion of those people, right? Not everybody will get paid higher, right? So that being said, I want to kind of go into today's webinar. I'll kind of explain with a few examples, right? So I'll take a real life example, right? What is an EV? So I'll start with the electric vehicle system and then go into embedded system, right? I'll kind of I've structured it into two ways. What is an EV? right? Essentially, it's a vehicle. So previously, vehicles were powered by internal combustion engines, right? Now, vehicles are powered by electric motor, right? And simply put, electric motor is powered by electricity stored in a large battery. So if you think about it, a battery essentially provides electricity, and the battery translates that electricity to the electric motor, and the electric motor moves the car, right? So very simple, right? uh, the EVs are increasingly popular. So is EV a recent phenomenon? Sorry, sorry guys, is EV a recent phenomenon? No, the EV is not a recent phenomenon. EVs have been there for a long period of time. What has happened is, usually there has been range anxiety, because say for example, when we are going in a IC engine car, there are multiple petrol bunks across, right? And previously the technology was not as mature to essentially give a high amount of range for an electric battery, right? Now, over the last decade alone, 2010 to 2020, over the last decade alone, the battery technologies have improved, and therefore the duration of battery essentially has been better. And this is a great example, right? Say for example, in our first generation smartphones, the battery would only stay 6 hours, 7 hours. Now in our smartphones, the battery is way much more, right? So it kind of lasts almost 2 days, right? And any electrified product, that's the case, right? And that's why EVs are becoming increasingly popular, right? Because they have good environmental benefits. They do not emit anything, right? And low running cost. Essentially, what does low running cost mean? So the cost of electricity is cheaper than cost of gas, right? Cost of gasoline. So that's the low cost associated with them. So this is simply an EV, and what are the advantages, right? Let me take an electric toy car to kind of explain a few things, right? What are the basic components, right? A battery, an electric motor, and a car wheel, right? The battery in an electric EV stores the electricity needed to power the car, right? The electricity from the battery is then used to power the electric motor, right? So battery stores the electricity. The electricity from the battery then is used to power the electric motor, and the electric motor essentially powers the car, right? These are three main components, right? Battery, motor, and essentially the transmission system, right? So if you think about it, right, the battery converts chemical energy into electrical energy. Electricity flows through the motor and powers the car, and the motor spins the wheel, right? There is a differential and everything, but this is the very simple example, right? Now, let us go into flow in detail, right? Direct current, DC, can be stored, and hence battery holds DC. But in general, we use alternate current in common, and AC cannot be stored. So we need to use power converters, right? So what are the components? So previously, the two major components were battery and motor. So in a car, now essentially you need something called as a power converter, right? So essentially, our mobile laptop chargers have adapters to convert this, right? So this is what we do in order to ensure that the required amount of current flows in the respective output units, right? Example, the power converter essentially provides the required amount of current flow. We need controllers, right? Batteries, motors, power converters, controllers. Batteries store energy, batteries store electricity. Batteries provide this electricity to motor to kind of move the powertrain, and converter essentially converts the DC current from the battery to AC, and control unit controls the flow of current, right? So these are four major components, right? So again, based on current input, the motor is also classified into two types: AC motor, DC motor. You might have heard this, right? Toy cars use DC motor since it is powered by the battery and is not recharged, right? For better performance in electric vehicles, we use AC motor, and it again needs a power converter to change the current from the battery, right? Why in a toy car you might not need a power converter, but in for efficiency in an electric vehicle you need a you need AC motor, and therefore you need also a power converter, right? So again, the electric motor then spins the wheels, right? So very simple. How are these products made? So any questions previously, right? So I just wanted to kind of introduce you to four important components: batteries, motors, power converters, and control units, right? This is essentially the reason you need to know this is when you are learning something, right? When you are focusing on, hey, I need to get into a EV domain, right? Electric vehicle domain, you need to then look into, okay, should I focus on battery management system? Should I focus on electric drives? Should I focus on motors? Should I focus on power controllers or control units, right? So simple. That's why I wanted to focus on that. How are these products made, right? So again, this is, we covered this. What is an EV? What is inside an EV, right? So I don't know if you can see this, right? This is an all electric vehicle, right? This is the battery pack. What you see in yellow is the battery pack. Let me kind of use a annotation so that you can. Okay, that's fine. Sorry. Right? Great. So this is a battery pack, right? This is the charging port which charges the battery. So there is a transmission here, right? Essentially, this transmission transmits the power to the wheels, right? And there is an onboard charger, and also this is an auxiliary battery, right? So essentially, you see two. So one is an onboard charger, and then a charging port. So that's a transmission system. There is a traction motor, right? Traction motor. Then essentially there needs to be a thermal system. So this is where if you're a mechanical engineer attending this, also an electrical engineer, you need to understand that every energy system creates heat, and therefore you need to make sure that heat is dissipated. You need a cooling system. So that's your thermal cooling system. This is a DC-DC converter, power electronics controller, right? So there's a controller, there's a power electronics controller and a DC-DC motor and a electric traction motor, right? So essentially this is motor generates the electricity is transferred to the motor, and the motor essentially moves those components which the transmission transmits the wheels, right? So let's go to components, right? Electrical energy is the most popular form of energy, we all know, right? Though rarely generated or used directly. Great use of control, conversion, and transmission. So a battery pack, right, is a pack of small batteries, right? Lithium-ion batteries is the most widely used. One of the important things, if you want to kind of build a career in battery management systems or in batteries, right? Very recently in Jammu and Kashmir, we have essentially discovered lithium-ion ore, which means that we can start manufacturing batteries in India itself. So this is going to be a huge discovery. This is going to be a huge for India, because there will be a lot of battery manufacturing units that will start being set up, right? So let's kind of look into an internal combustion engine versus EV, right? So very simply, in internal combustion engine, there is chemical, which is the petrol or diesel, kind of becomes heat, which is through combustion in the combustion chamber. This heat is essentially used to move into mechanical energy, right, which is the crankshaft rotates, and then it kind of transmits, that power is transmitted to the transmission and to the wheels. In electric vehicle, what are the advantages? It has fewer rotating components. A crankshaft, I don't know how many of you know, crankshaft is a very big shaft which essentially rotates. There is piston, engine, cylinders, and everything, right? So a lot of moving components. Whereas in electric vehicle, there's batteries and essentially a motor, right? The converter, power converter, essentially converts and provides the right current, and the controller controls the flow of current, right? And the motor essentially uses the transmission. Very simple. Again, this is a simple representation. So just want to kind of give you an example, right? So again, what are the main components? Batteries, converters, controllers, motor. In a electric vehicle, these are the 4 important components, right? Again, this is the advantages of EV and ICE. I'll kind of skip this quickly, right? There's a hybrid electric vehicle where there is a series parallel where essentially both the power generation from a IC engine or the battery essentially gets connected to the motor. Then there is your pure electric vehicle, right? Where the battery to motor to transmission happens, right? So what are the high level? Now that we understood the different components in a electric vehicle, right? I wanted to go into what are the high level challenges, right? Guys, I'll take a small break and see if you have understood till now. I want to ask a few questions, right? What are the 4 major components in an electric vehicle? If you can answer that in the chat box. What are the 4 major components in electric vehicles? Ajit is saying battery. What is the second one? Ajit, battery management system is included with battery. Hanumant, battery and motor. Yes, 2. Ritik, lithium ion is a battery. Transmission system is something else. Converter, battery, motor. Yes. Afran is saying it correctly. Battery, motor, converter, and controller. Right? Okay. What does battery provide? Why is battery important? What does battery provide? Can you guys say what does battery provide? Energy source, right? Battery provides the energy source. What does a motor do with the energy source? It essentially generates the power to rotate the wheels and essentially transmit. Why do we need a converter? Why do we need a converter in a electric vehicle? Hanumant, DC to AC, yes, correct, absolutely. Why do we need a control unit? Why do we need a power control unit? To control the power. Vishnu is saying absolutely the correct thing. So guys, I will just take a step back, revise, right? In electric vehicle, if you want to build a career in electric vehicle, you need to understand what are the major components in an electric vehicle. Apart from say for example, transmission is there in IC engine, it's here. The wheels, the vehicle dynamics, all is here. Since you are an electrical electronics engineers, I'm going to stick with the electrical components. The major components are batteries. The second thing is motors. The third thing is your power converters, and the 4th thing is a control unit, right? So these are the 4 things. So what are the high level challenges in designing this product, right? The problem is shorter driving range and degrading batteries. So batteries degrade, right? Like how if you have a remote in your home, over a period of time, your remote is the battery in the remote essentially goes off, right? You need to change the battery, right? Similarly, battery degrades, and also essentially shorter driving ranges. The other aspect of it is the infrastructure, right? Even it can be shorter, right? It can be 200 kilometers, 150, but if there is a charging infrastructure which charges fast, then I can charge easily, right? And the third thing is, which I have not noted here, is the time taken to charge, right? Usually the time taken to charge is half an hour, 45 minutes. That's a long period of time, right? Long period of time for you to wait, right? That's the third thing. Again, what power semiconductors that you need to use. Then the reliability of powertrain components, such as the battery, motor, and power electronics, right? So those are the things. And then adapting to the fluctuation in the automotive supply chain, right? So these are the high-level challenges in designing this product, right? So now I wanted to kind of get into various systems and how they work, right? Again, this is very, very simple. Again, speaks about the same thing. What are the skills required? So let's go to now that we understood the major components, let's kind of go deeper into what are the skills required to build, right? So for example, right, application of various subjects put all together. Say, for example, in electric vehicle, right? So there is batteries, electric motor, digital communication. So whatever you see in your dashboard, right, that's digital communication, your power converter and your controller, right? So this is what a EV is made of: electric motor, power electronics, embedded systems, battery and its chemistry, digital communication, vehicle dynamics, control systems, thermal management, right? So the electric vehicle is an interdisciplinary product, right? And therefore you don't need to exactly be interdisciplinary, but if you essentially know one particular area very deeply, and you can connect the next discipline, say for example from the electric grid to charger to batteries to power electronics, microcontroller, then to motor, vehicle dynamics center, and all those things are interdisciplinary. If you know a few of this, you will essentially be good. Himanshu is asking, sir, please explain embedded system. Will definitely, Himanshu, right? So why is simulation important, right? Now, okay, great. So you said all these things. There are four important components and whatnot. So how can we essentially go and build into these? What are the job roles out there, and what do we do, right? See, guys, very simple, right? So we will have a conceptual in an electric vehicle or any product development, right? First, there will be conceptual design. Most of the conceptual design is driven by mechanical engineers using computer-aided designing, right? Then you take that and start simulating, right? So in the simulation is where a lot of engineers, like electrical engineers, kind of come into play. Again, there are two types of simulations or setting up, which is either you're in embedded systems, building the whole product life cycle in embedded system and simulating it, or validating it, or in model-based development. In model-based development, you essentially have system-level models where you simulate these system-level models, right? Once you simulate, then you test, and then essentially there is a loop that goes on. And then if at the final test, when everything goes out, hardware prototype and manufacturing and release, right? 70% of engineers' effort are on simulation and testing. The software tools that are applicable of EV area are MATLAB, Simulink, Spice Simulation, ANSYS Maxwell, Altium Designer, C++ programming, right? These are these are some of the tools that are applicable, right? So now, what are the fundamental concepts? How say, okay, this is simulation and testing is where 70% of engineers' effort is there. What are the fundamentals that I need to work? How do I start? Right? If you want to get into this domain, the domain knowledges on following systems are very important. Vehicle mechanics and dynamics, right? Again, vehicle mechanics and dynamics can be the fourth component that you can learn, but as a electrical electronics and instrumentation engineer, you should have very good understanding of electric motors, power converters, and control systems, right? These three subjects, if you have very good idea, then you can adapt those three aspects to vehicle mechanics and dynamics, right? Very simple. And if you want to get started in the software tool, you should get used to the software environment. You should know how it works in the background. Software is essentially, right, one thing that I have heard a lot is essentially a software. You just clicking on buttons is what is not using the software well, right? So you can click on buttons, you can get color simulation, but or graphs. But if you do not know what those graphs mean, if you do not know what those buttons essentially do in the background, right? You are essentially not doing simulation. You're just playing with a tool, right? So now you need to get used to the software environment and know how it works in the background. What is the fundamental equations that a particular software is solving, right? Then translating, so you have a boundary condition, you have a real life scenario, you need to take the real life scenario and translate into a simulation, right? And essentially once you have the result, implement that in and learn from those results, right? So this is the very simple aspect of it, right? So how can Skill-Lync help you, right? So the entire postgraduate program has been created as per the latest industry trends. We have curated the programs into 4 tracks. One is the embedded software. This is where the control unit, right? When I said the control unit, right? Embedded software essentially plays a major part in the control unit. Then the model-based development. Model-based development simulates one, so it's a one system level modeling of the entire system, right? So if you don't understand, so essentially MATLAB and Simulink allows you to simulate the whole electric vehicle in a one-dimensional format. And that's what model-based development means, right? Then the EV system design and the e-drive system. So these are the 4 major tracks that are there. And these 4 major tracks enables you to kind of focus on the 4 components that we spoke about, right? EV system design, right? If you want to get better in an EV system design, you need to kind of have a very good understanding of MATLAB and Simulink basics. You should have a very good understanding to hybrid electric vehicles. You can use the same MATLAB and Simulink. You should have a very good introduction to controls of electric vehicle. Then you should have a good understanding of lithium-ion battery system for electric vehicle. And then you should have a very good understanding of fuel cells and ultra capacitors for electric vehicle, right? If you want to build in EV system design, this is what we would recommend you to look at. If you look into e-drive, right? So here is where essentially you need to, so MATLAB and Simulink basics, I'm going to say that's very, very fundamental. You need to have. So what is MATLAB? Rahul is asking, what is MATLAB? MATLAB is a software that allows you to simulate all these aspects that I've been speaking about, right? So that is a software, Rahul. So that's the simplest explanation that I can provide. Then once you understand MATLAB and Simulink basics, you need to understand design of power converters, right? For electric vehicles, right? How to simulate and design power converters for electric vehicles, right? Again, what are the fundamental design concepts of power electronic converters for industries? And what are DC-DC converters, AC-DC rectifiers, harmonics and related standards, and electric motor design using MATLAB and ANSYS Max, right? These are the fundamental concepts that you should look at. So Ramesh, here's the previous slide, EV system design, right? So this is EV system design. This is e-drive system. If you want to become embedded systems, so embedded systems primarily works on the control units, right? So you need to have very good understanding of embedded C, right? You need to understand fundamentals of embedded system, AVR bare metal programming, software verification and validation system, so that you can test and verify and validate and system test for hand code. C++ is important, and Linux driver development is important, right? So these are the aspects that you should look at and understand in embedded system. Similarly, for model-based development, introduction to model-based development using MATLAB and Simulink, embedded C essentials, software verification and validation, and automotive embedded systems and AutoSAR. AutoSAR is a very, very, very important module, right? So see what, say for example, one of the things that, where can you learn all these things, right? Again, you can learn, you can search in the internet, or what are the ways that you can look at it, right? But more importantly, these are the, in Skill-Lync, we have built coursework in electric vehicle and embedded systems primarily on these aspects of it, right? Now, if you learn all these things, right, what can we look at, right? So essentially, company categorization, right? What kind of jobs can we look at, right? See, there are 3 types of jobs, right? OEMs, tier 1 suppliers, tier 2 suppliers, tier 3. There are also engineering services companies, right? Engineering services companies are also hiring in bulk, right? So that's something, right? So these are, so tier 3 companies, see, OEMs are your original equipment manufacturers, people who manufacture the final product are your OEMs. Your tier 1 suppliers are people who supply, say, your batteries or motors to your OEM suppliers. Tier 2 suppliers are people who supply your components to tier 1 and so on, right? So this is your overall overview, right? So all major automobile companies, along with technology giants like Google and Apple, are working on EV, right? You might have heard this news, right? All automotive manufacturers are working on electric vehicles, right? So it's not just Tesla anymore, right? Every automotive company has the electric variant that are building. Now, as I said in the first slide, India is going to become a big manufacturing hub, but India can only become a big manufacturing hub if we have the engineering talent, right? We have the talent, but now do we have the skill set to succeed and get these jobs and grab these jobs, right? That is essentially what you should all think about, focus on. Does not matter where you come from, does not matter you are from a tier 3 college, tier 2 college, tier 1 college, does not matter if you in undergrad you have only got 60 percentage or 80 percentage or 90 percentage, right? If you have the right level of desire, and if you are essentially focused and putting in say 20 hours per week for 8 months, you can be really good in one of these component skills, and therefore can be able to grab your opportunities, right? Just wanted to make sure that I'm very clear out here, right? What are the job roles, right, on learning tracks? So let's say these are the learning tracks that we spoke about: embedded software development, model-based development, EV system design, e-drive system, right? What are the target job roles, right? Embedded software engineer, embedded software validation engineer, device driver developer, embedded application engineer. So if you know embedded software, these are the job roles that you should search for, right? In model-based development, MBD engineer or MBD model-based application developer, right? In EV system design, it's EV system engineer, right? E-drive power converter engineer. So the majority of jobs are in this two, the first two, embedded software and model-based development. Again, key skills. We looked into key skills already, but I'll speak about this. This is a slide that you should screenshot immediately. This is very important, will help you look into the right skill sets. Key skills to be developed are embedded C fundamentals, embedded C essentials, fundamentals of embedded systems, AVR bare metal programming, software validation and verification, right? Again, model-based development in MBD, system design, code generation, MIL, SIL, right? ADAS, automatic driver assisted systems, right? Embedded C, right? Again, in EV system, MATLAB Simulink, fundamentals of electrical engineering, powertrain architecture, battery design, e-drive systems, again, electrical concepts, power converters, topologies, power converter topologies, design of power converters. What is the background required, right? Yeah, Hanuman, sorry if I've said automated driver assistance system into advanced driver assistance system. Thank you so much for correcting me. Background required, embedded systems, programming using C, interfacing sensors, actuators with microcontrollers, system development, logical skills, and developing Simulink models, circuit design, right? Electrical circuits and fundamental of electrical concepts, power electronics, semiconductor devices, right? This is the target job roles in each of these subsystems. These are the skills that you need and the background required, right? So if you have this, you should be able to look into it, right? So Surya is asking, I'm from the domain of embedded system pursuing BTech in third year. Beside a campus placement, how can I get placed out of campus with my own talent, and how to gain knowledge in the main areas? Please give some knowledge about this and help us. Guys, if you're in your third year, right, you have the time and the ability to learn all these skills, right? Again, look out for places where you can learn. Skill-Lync also provides a lot of these skill sets in detail. I think we are one of the best platforms in India that essentially focuses on these skill sets, right? In teaching these skill sets. All you need to do is focused development, right? Say, for example, if you basically go take a look at Skill-Lync profiles, right? So Skill-Lync students work on multiple profiles. So for example, if you basically look into electrical, right? So what you should do is or embedded. Just primarily, if you are in your third year or fourth year, if you have the opportunity to work on projects, right? So you end up working on a lot of profile. You can build a very strong profile, right? So that will essentially help you to succeed in your career, right? So that's what I have seen primarily. So that's what I can essentially say. So these are skilling profiles. You can go out here and take a look at these profiles, and you will understand what kind of projects that you should work on, right? And yeah, so I'll kind of go back, right? If you have any other questions, I'll come back, but I'll go back to this. So, okay. So now that we covered electric vehicles and the job roles and the skills that are required, right? I'll kind of go into embedded systems. I know I have roughly around 15-20 minutes. I'll kind of quickly finish the embedded system part of it, right? So let me kind of take a example, right? So digital rear view mirror, right? Let's take a digital rear view mirror. What are the components involved, right? So there is a camera, there is an embedded processor, and then a digital display, right? So the input device is what a camera is, right? The camera captures the image of the rear of the vehicle and sends it to the embedded processor. So this embedded processor processes the image and sends the image to a digital display, right? And digital display is the output device. Digital display processes the image from the camera, right? So here, the Hanumant, I will finish this embedded systems and kind of explain also, right? Flow in detail. Let's kind of look into the flow in detail. Cameras, right? The cameras are the first component of embedded system and are mounted on the rear of the vehicle. They capture images of the rear view, which is then sent to the embedded processor. Embedded processor, right? What does the embedded processor contain? It contains a microcontroller, memory, and input-output peripherals, right? These are the things that an embedded processor essentially has, right? So the embedded processor, what is the embedded processor? Essentially, it's a computerized module that is integrated into the electronics of the vehicle, right? It is responsible for processing the images from the cameras and sending them to the digital display. It is also programmed to detect any changes in the image and adjust accordingly, right? So think about that. In the image, essentially that vehicle comes, it essentially needs to capture that and send it, right? So as I said, the embedded processor typically consists of a microcontroller, memory, and an input-output peripheral. The microcontroller is the main processor and is essentially responsible for controlling the other components of the system, right? Very, very simple. Microcontroller controls the other components of the system. The memory is used to store data, obviously, right? And instructions for the microcontroller and input-output peripherals, right? The input and output peripherals are responsible for the communication between the processor and the external environment, right? So digital display, essentially, digital display is nothing but your rear view camera. Now they have digitized it, right? So how are these products made, right? So what is an embedded system? It is a system which basically performs certain computational operations on the given input, right? And there is a minimum hardware and dedicated software, right, to produce a useful output. So in our previous example, the minimum hardware would be your camera and the mirror, right, or the output display, and the software would be your embedded system, right? So your general embedded systems are programmable, right? So they're easily programmable, and this is where your embedded engineers come and program these embedded systems, right? So they have their memory is a very low power systems with very less memory and limited peripherals based on the applications, right? Any consumable durables, any automotive electronic systems, right? Industrial machines, medical equipments, handled PDA, right? Your smartphones is also an embedded system, right? Like all those things is essentially what an embedded system is, right? In the embedded system development cycle, there are these 5 phases, right? Product designers, system integrators, software engineers, test engineers, maintenance engineers. In the product development cycle, essentially there are 5 aspects of it. Product designers. So product designers are primarily responsible for designing the overall system of components, right? Overall system and its components are designed by the product designers. And if you look at it, they must ensure that the system is optimized to do its intended purpose, as well as is reliable and meet safety requirements, right? System integrators are responsible for assembling the integrating the various components of the system, right? They ensure that all of these components work together effectively to provide the desired functionality. So for example, as a system integrator, I need to make sure the camera, and my output screen and the embedded system is integrated in the right way, so that there is no delay, right? Or whatever I capture in the camera is seen in the screen, right? Again, software engineers again are embedded software engineers, are responsible for developing the software that is on the embedded system, right? So test engineers are your verification and validation engineers, right? Who make sure it is reliable, secure, and performs as expected. And maintenance engineers are responsible for maintaining the overall system, right? So what are the high-level challenges, right? The high-level challenges are software challenges, testing challenges, cost challenges. So you need to develop the user interface, the algorithms for controlling the camera and the display, and any other software necessary for the system. You need to test the hardware and software to ensure it meets the performance requirements. And cost, you need to make sure it's cost effective, right? So these are the three major high-level challenges in designing the product, right? So building blocks of so again, we spoke about this. Give me 1 minute. Sorry. So architecture, so this is the building blocks of digital rear view mirror. Now, what is the architecture? So architecture of an embedded system is very simple, right? Input system, embedded system, and output device. In our case, rear view camera is the input system. Our output device is LCD display. The embedded system itself is your hardware, firmware, and RTOS, and the application software, right? This is the structure of your embedded system, right? So what are the skills required, right? Again, we spoke about this previously also. So C programming for embedded application, right? This is for, you need to essentially build the software. C programming for embedded application. You also need to have a clean and safe coding practice, right? In very important, not only in a EV car or any product, you need to be compliant in the software development, right? Meeting compliance in the software development of the particular product, and understanding the requirement and converting into code, right? What is the input? How these inputs should be processed? What is the time at which, how much lag can be there, right? What are the algorithms that you can use these inputs and convert them into desired outputs? And optimizing the software for memory and speed, right? So I don't know how many of you have seen the autonomous vehicles and how they detect people, right? Take a look at it. You can just Google how autonomous vehicles see people and the road, right? So you will see images. So all those are embedded systems, right? And that's the future, right? So therefore, it's very important for us to look at exactly, Hanuman, LiDAR, right? So there is LiDAR, there's a lot of other things as well, right? So more importantly, you need to have logical thinking and algorithms and programming, right? If you look into embedded software engineer, these are the technology that you need to essentially know, and these are the tools to kind of use in the technology, right? So embedded programming, microcontroller fundamentals, bare metal programming, communication protocol, model-based development, verification and validation. V&V is verification and validation. This is your tools, right? You can take a look at this as well. Now, company categorization, right? What are the hardware companies, right? Intel, Nvidia, Texas Instruments, those are the hardware companies, right? In software companies, Bosch, LTTS, again, Intel also is a hardware and a software company. So the beauty is, in the hardware company, they might be the input or the output devices. The software companies might be the embedded systems. Then you have the integrators. Automotive sector is the integrators, right? And consumer electronics is also the integrators, right? So yeah, so this is pretty much the classification of the companies that you can essentially also look at when you are applying for jobs, if you have all these skills, right? If you have these skills, these are the type of jobs that you can apply for as well. So yes, I think we have come to the end of the webinar. Okay, I'll take a few questions at this point in time, and I can essentially see a few questions coming in. So first up, right? So I'll kind of summarize. There are a lot of job opportunities for mechanical, electrical, electronics, civil engineers that are already present and that are being built, right? What we see is that the opportunities out here is extremely high, and we need the right amount of talented engineers who have the necessary skills. All of you are very, very good talent, right? You just need to make sure that you have the right skills, right? And that's primarily what we are looking at, right? So what is an embedded system? Again, in a short way, right? See, primarily embedded system, what does it do, right? It has essentially, it takes input and transfers it into output, right? And in a way that the humans understand, right? So it has a microcontroller, which kind of a memory and the input output peripherals. And so if you basically look into the development cycle, so again, so let me take a, so this is the whole holistic, simplified explanation, Rahul. So take a look at this. What is IoT? IoT is Internet of Things. Yala. So there are a lot of job opportunities that are available in India, especially for freshers. You can look at anywhere between 4 to 7 lakhs. For experienced people, you can easily look at 30–40% hike if you have the right skill sets. Even if you are in a domain that if you're a electrical engineer, you got into CTS, TCS, but you want to kind of switch back into your core engineering domain, right? And you've been spending 2 years, you do not have the relevant experience, right? It's still, I think the opportunity is still available. If you have the right skill sets, right aspects of it, then you can definitely take a look at it, right? So that's one thing that I wanted to say. A lot of people are asking what are the best courses for EV, right? I'll kind of look into what I will kind of look into is so you can look at electric vehicle postgraduate program in Skill-Lync. So this is so this is one of the programs that I would kind of look at. So again, some of them asked about the placements as well. So this program essentially has a very good structure. As I said, it has embedded system, model-based development, EV system design, and drive system, right? You can take a look at the entire thing and you can see what are the syllabus out here as well, right? So that's one thing that I would definitely recommend. The other aspect of it is if you're looking at placements, right, you can also go to skilling.com/recent placements. We have roughly around 2,000 placements at this point in time. Some of the top companies hired from our state, Tata Technologies, BYD, Cyient, Ashok Leyland, right? A lot of other companies hired from us. Cyient and West Global are essentially very frequent recurring recruiters for us, right? Every month we roughly meet 150 to 200 placements at this point in time, right? So this is if you are someone who is interested in our coursework, what you can do is you can write a detailed question about what you have, and you can put your name, email ID, and phone number, and we will reach out to you and provide you all the details, right? So that's the Vivek. If you have the feedback form, can you please provide this in the feedback form?
Yeah, Surya. I'm just sharing the link. 1 minute.
Hanumant, I'll kind of, yeah, sure, Hanumant. So Tejas Sivasai, sir, can you give us confidence to future engineers that so many of them who are interested in one domain and choosing another domain in BTech and another domain in job that we have scope in India? Guys, if you are interested in a particular job role, right? That in a particular, so if you are interested in any particular aspect of in any particular career opportunity, right? Your ability to pursue, if you have a particular dream, your ability to pursue that dream uh, is all dependent on the amount of effort that you put in, right? So I'm a mechanical engineer and I wanted to build a career in mechanical engineering, and I've been able to do that. So I think that there is no reason why you cannot essentially pursue your dream, right? Again, this is not a session where I'm asking you to enroll in a skilling course. You don't need to enroll in a skilling course. If you have the ability to figure it out anywhere, right, you should essentially do it there. And what we have seen is, if people have the right amount of knowledge, and if they have the right amount of practice, they have the ability to succeed, right? That's the only thing that we have been able to see. Any other questions, guys? So again, if you can, you please let us know how the was the session helpful? Did you learn something from this session? If you can just put it in your chat box, that will be helpful. Thanks, Hanuman. Harsha, can I settle in electric vehicle domain through VLSI? Yes, Harsha. Again, if you have a particular area of interest and if you go deeply, right, you definitely can build a career out of it. So there is no reason why you should not. And you should essentially look at what are the opportunities that are there, and you need to go deeper into that, right? So yeah, thanks, Afrin. Thank you for the feedback.